So today we're going to do lesson 33, quadrilaterals. Now quadrilaterals are four-sided polygons. So four-sided polygons. Now there are more than just quadrilaterals. Quadrilaterals is a very broad term. We start to say there are subcategories of this. And there are three categories of quadrilaterals. There are quadrilaterals where none of the sides are parallel. There are quadrilaterals where exactly two sides are parallel. And then there are quadrilaterals where both pairs of opposite sides are parallel. So we start to get narrower and narrower with what are quadrilaterals. So there are subsets in there. The first one that we're going to talk about today are parallelograms. And parallelograms, and I've got the properties on here, so the different slides have the different properties. It starts on page 233. On page 233, you'll start to find these boxes of the various types that I'm going to have on the slide. I am not going to give a lot of time to copy these, okay? So sit back, relax, let's listen, let's do what we have to do here to understand what they are. Part of your homework is going to be copying those down, okay? So the properties of parallelograms. Parallelograms, both pairs of opposite sides are congruent. So we'll have there is opposite sides are congruent. What would a parallelogram look like with when we have both sides of opposite sides are congruent, both pairs of opposite angles are congruent, and the diagonals bisect each other? What does it mean to be bisect? To bisect something is to cut it in half. So the diagonals cut each other in half. And then any pair of consecutive angles is supplementary, which means that adds up to 180. So what would a parallelogram look like? Well, that means both pairs are parallel. I think, we could have a rectangle, right? This would be both sides parallel, 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 parallel. The little arrows mean parallelness. And if it says the diagonals bisect each other, so that diagonal and that diagonal cut each other in half. That's what it means. Okay? Moving on. We talk about one of these sets of parallelograms, and that first one is called a rectangle. So maybe we move that up here. Properties of rectangles. And I had that shown this earlier, that all properties of parallelograms apply. So it means parallel sides on opposite sides, right? Both pairs. And it says all the angles are right angles. So if you need to, you could draw that in. If I make this, make that a little bit bigger. That means that's a right angle, that's a right angle, that's a right angle, that's a right angle, correct? And then it says the diagonals are congruent, which means that in a rectangle, your diagonals not only bisect each other, but they are also the same length. Okay? So the thing is, it goes really quickly to go through all of these, to say them and do that. So that's why I'm not having you copy them all down right now. Okay? I want you just to think, does that make sense about a rectangle though? I hope so. Now we can talk about the properties of rhombuses. Let me make that a little bit larger for you. And so we have this, properties of rhombuses. A rhombus, all the properties of a parallelogram apply. All the sides are congruent. So now we're getting closer to the fact that maybe we have a square, right? Which is probably the next one, obviously, one below this. So the sides are now congruent. The diagonals, when you draw them in, are perpendicular. What does that mean? No, they're going to intersect, but they have to intersect to be perpendicular in a way, which means they form 90 degrees, right? That means all of those angles, and those don't look the best, all of those angles are 90 degrees to each other. They're perpendicular. The diagonals bisect the angles. Ooh. So not only do they bisect each other, that means that they form equal parts on each side. So those are the same as these ones here, right? That was the definition of a parallelogram. We also have the fact that it bisects angles, which means what?
Or multisects. That's right, you should have left it up there. Bisects angle.
It means that the angles are cut in half. So this angle here, which I'll change colors, this whole angle here is cut into two equal, wow, that was not good, two equal angles on each side. That means it bisects that. And the same thing would happen here with those two angles. They would get cut in half. Okay? All the angles are cut in half. That's good to know. We need to know these properties. As you can hopefully tell, that the more properties I give you, the more likely you're going to have to prove things. You're going to have to go into proofs, and you're going to be given now different types of shapes, and you're going to have to use different properties of parallelograms, definitions of or properties of rhombuses to be able to answer those. Okay, so are we ready to move on? Let's clear, not that. Let's use the eraser. And now let's move the picture up to properties of squares. Properties of squares, all the properties of rectangles and rhombuses apply. Cuts the angles in half. Sides are all the same. Parallel sides opposite each other. Forms right angles and are perpendicular on our diagonals. And now the third thing that adds to it to be a square versus a rhombus, is the diagonals form four congruent isosceles right triangles. They're isosceles. Well, does that not make sense if this is the same as that, and this is the same as that now? Because our diagonals are the same, and they're cut in half, that all of those would be the same? These all formed right angles, correct? So therefore, they're right triangles. Two sides are the same. So therefore, they're isosceles triangles. It's a square. All your side lengths are the same. So that creates four identical triangles with the center or the diagonals being cut. That's what that means. The diagonals form four congruent isosceles right triangles. Okay? Next thing. Conditions for a quadrilateral to be a parallelogram. So this is kind of going back here. A quadrilateral is a parallelogram if any of the following conditions is satisfied. So if you are given any of these four things, then you can say that it's a parallelogram. Both pairs of opposite sides of the parallelogram, the quadrilateral, are congruent. So when I have a quadrilateral, and I can say that this angle and that angle are the same, and these two angles are the same, you know it's a parallelogram. Because therefore your opposite sides will have to be parallel to make that happen. For alternate interior, alternate exterior, and all of that kind of angles to happen. We also can say one pair of opposite sides of the quadrilateral is congruent and parallel. So if I told you the top and the bottom of this picture were congruent and they were parallel, the only way to connect them is if these other sides would also have to be parallel and congruent. It's the only way you can construct it and make that happen. 3, the diagonals of a quadrilateral bisect each other. So the only way that you can cut a diagonal through the center or through the middle of the object and bisect each other is if they are, or if it is a parallelogram. And then the last one is both pairs of opposite angles of a quadrilateral are congruent. So both pairs of opposite angles are congruent. And again, that goes back to both pairs of opposite angles of a quadrilateral are congruent. It kind of looks like the first one, doesn't it? So why do they repeat that first one? Oh, the sides, sorry. In number 1, I said it wrong. Number 4 was what I hinted at before with our angles. I'll change the color. Sorry, my bad. I said the angles in the beginning were the same. That was number 4. Number 1 is both pairs of opposite sides of a quadrilateral are congruent. The only way to construct it, I'll redraw it, is if these sides are the same and these sides are the same. It's like a box. Either the box is going to have the same dimensions or same length and width in a way, it's just that it's going to be pushed over sideways or it's going to be standing straight up and down. So therefore it has to be a parallelogram. The sides will have to be parallel. So if I push this over sideways, the side lengths still have to be there. That's number 1. Conditions for a quadrilateral to be a rectangle and a rhombus. So they're there. If a quadrilateral is a parallelogram and its diagonals are congruent, then this parallelogram is a rectangle. If all 4 angles of a quadrilateral are right angles, then it's a rectangle. You guys know that, okay? But these are allowing us that if we see a diagram and we see that it's got 4 right angles, then we can say this quadrilateral is a rectangle by definition of a rectangle, right? Those types of things. If a quadrilateral is a parallelogram and either of its diagonals bisect the angles whose vertices it connects, then the parallelogram is a rhombus. So again, if your diagonal bisects the angles, it's a rhombus. If the diagonals of a quadrilateral are perpendicular bisectors, form right angles to each other, then the quadrilateral is a rhombus. And again, we're starting to get closer to that idea that it's going to eventually be a square. So the more detailed you are, the more you get closer to a square, which we'd almost say is like the perfect rectangle in a way, right? And then we get to something like this, where it's not a parallelogram, it's a trapezoid. So these are the properties of trapezoids. Properties of a trapezoid would have the area of a trapezoid equals 1/2 the product of the length of its altitude and the sum lengths of its bases. The median of a trapezoid is parallel to its bases, and its length is 1/2 the sum of the length of its bases. What I think I forgot to put in here is what is a trapezoid. So maybe I'm going to move this down. If I move that down, what is a trapezoid? The trapezoid is a parallelogram, but only has one set of parallel sides. So it's still a quadrilateral, but only one set. So generally, we generally see trapezoids that kind of look like this. And so you have base 1, which we'll call the bottom, base 1 and base 2. There's a height, and that's where we get number 1. The area of a trapezoid is equal to 1/2 the product of this length of its altitude, or its height, and the sum length of its bases. So area equals 1/2 B1 plus B2 times its height. It's kind of a nice function about this one. I could zoom this in, write something a little bit bigger, but yet when I zoom it close, it actually looks nice. I like that. What about the median? What's the median of a trapezoid? Well, the median of a trapezoid, if I go here, the median of a trapezoid, let's make some space in here. Okay. The median of a trapezoid is if it's in between the bases. So it'd be the direct middle between two bases. This is what I call the median. That's the median. It's between the two bases. And to find that, it's half the sum of the lengths of its bases. So if I go down here and I put it in, the median is equal to 1/2 B1 plus B2, at least as its length. The median, it's kind of like the average, right? Add them together, divide by 2. So whatever this base is, B1 and B2, add them together, divide by 2, you get the length of its median. And then we go to properties of an isosceles trapezoid. What's an isosceles trapezoid? It's kind of like the picture that I've been drawing the whole time. It says the lower base angles are congruent. So boom, boom, those are congruent. The upper base angles are congruent. That's the same as that. The diagonals are congruent. So those are the same. And any lower base angle is supplementary to the upper base. So if I add these, this angle and this angle, or these two angles, they add up to 180. So it's very cool. It's very cool like that. Well, it should make sense that if you add up just these two together, you get 180. Definition of parallel lines, those are not be alternate interior, those would be interior angles. Interior angles add up to 180. And the fact that the two upper angles are the same, then it means it wouldn't matter if I added the bottom left to the top right or the top left. It doesn't matter. Okay? Any questions there? And that would be it. So what I want you guys to do for your homework. So homework is going to be copy all the boxes of info from lesson 33 into notes. It's in your book. I want you to put your notes because I want you to have some. I want you to say it. I want you to see it. I want you to write it. It gets it stuck in your head. Then I would like you guys to do page 240, 4 through 7.